Hi viewers, you are welcome back. Today we are going to solve two simple questions. Before I proceed, let me just touch on one or two things. Remember, in our previous lesson, we said that in an incompressible static fluid, P2, that is pressure 2, is equal to P1, that is pressure 1, plus rho GH, where rho is the density of the fluid, H is the height of the fluid, and G is the acceleration due to gravity. Now, so we have this way, P2 is equal to P1 plus rho GH. Now, when we have this, let's say this is level 1, and for that matter, the pressure at level 1 is pressure 1 or P1. That's P1. And this is level 2, and for that matter, the pressure over there is what? P2. And the interval or the difference between level 1 and level 2. In other words, the pressure difference here from here to here is denoted by what? By H. That is height. Do you get it that way? Yeah, so that's the pressure difference or the pressure gradient. Or you can also say where H is, you can say it is the height below level 1. Do you get it that way? Yes. You can play around with it, provided you know what you are saying, or provided you understand what you are doing. When we are saying pressure with respect to this depth or this height, so I'm calling it pressure at that particular depth, is given by the formula rho GH. I hope you remember this. Okay. This expression is valid when and only when the fluid is what? Is an incompressible static fluid. Incompressible in the sense that the density of that fluid does not change. In other words, the density of that fluid is constant. And static in the sense that the fluid is at rest or it is stationary. Let's write down the data. Calculate the pressure in PA, that's Pascal, at a depth of 2.5 meters. So simply, the meters tells you like its height. So H is equal to 2.5 meters due to water in physiotherapy bath. What is the total pressure at that depth? The density of water, if I give you rho to be 1,000 kilogram per meter cube, and of course your G is what? Your 10 meters per second squared. You know these three quantities, and you know the relationship that is between these three quantities. What's the relationship? Rho GH. And note, rho GH is the pressure at the depth, at the particular depth. So let's do our simple substitution. Our density is given by 1,000, so 1,000 times gravity is what? Is 10 times my H. My H from the question is 2.50. So mathematically, if it comes, how many zeros? 1, 2, 3, 4. So we move it 4 times. So we get 2, 5, 0, 0, 0 volt Pascal. So this is the pressure at that particular depth. You see, it's very, very simple. It's not difficult at all. Just understand the concepts, and we are free to proceed, or we are free to move on. Now, this is not the end. Read the question carefully. Say, calculate the pressure at a depth of 2.50 meters due to water in physiotherapy bath. What is the total pressure? Listen to the total pressure. And we've spoken about total pressure. And we said total pressure is the same as what? The absolute what? Pressure. Which is the pressure measured relative to a perfect what? Vacuum. And what is the relationship between absolute pressure and the gauge pressure? We said that. Remember, we said that the absolute pressure is given by the gauge pressure plus the atmospheric pressure. Did you get it that way? Yes. It's just simple as that. Okay. Now, we're going to find for the absolute pressure. Indirectly, do you know what we have found? Before you can be able to calculate for the absolute pressure, you should know the gauge pressure. Please take note. The rho Hg is the same as the gauge pressure. It's the same thing. So my absolute or the total pressure. Remember, I said my gauge pressure is the same as what the pressure at that particular depth. So we are going to be the same what magnitude. So my gauge pressure now is what 25000 plus. Now what is atmospheric pressure? What's the magnitude of the atmospheric pressure? At sea level, the atmospheric pressure is equal to 1 atmosphere. But here they didn't say sea level or what have you. They said calculate the pressure in Pascal. And what is the magnitude? So remember, so the atmospheric pressure, remember I told you that 760 millimeters of mercury is equal to what? 101325 Pascal. You see, so that's the magnitude of the atmospheric pressure. So atmospheric pressure is what? 101325 Pascal. So they are saying we should work in what? In Pascal. But if you are told to work in atmosphere, you will not use this, use what? 1 atmosphere. Please do you understand that? So I have it to be, I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Okay, so that's that. So by the help of my calculator, when I add them, I'm getting 1, 2, 6, 3, 2, 5 Pascal. Hello viewers, this is how we go about such questions. Please, they are not difficult at all. Be encouraged, be inspired, be motivated. Just understand the questions and you can apply them in all dimensions. Do you get it that way? So this is the end of question 1. Let's take the question 2. Having understood this, let's start with question 2 and realize that question 2 will become very, very simple for you. Okay. So that question 2 reads, the pressure inside a tank is 4.2 atmosphere. You see now, it is not 4.2 Pascal, yet it is what? Atmosphere. So here we are treated to work in what? In atmosphere pressure. You understand it that way? So please take note of the various units of measurements. So the pressure inside the tank is 4.2 atm. At sea level, what is the gauge pressure inside the tank? Let me tell you something. When you have a tank, the pressure inside that tank is what we call what? The absolute or the total pressure. Yes. Did you understand that way? Because inside the tank, easy. The tank has been enclosed. So there is a perfect vacuum created within the tank. So that is what the absolute or the total pressure inside what the tank. Do you understand that way? That is that. So what is the relationship between absolute pressure or the total pressure and gauge pressure? You know that absolute pressure is equal to my gauge pressure plus what? My atmospheric pressure. What were we asked to find? Well, this time around, we're not asked to find the absolute pressure. We said what? Gauge pressure. So make the gauge pressure extracted from here. So now you know that gauge pressure now becomes, when I transpose this, I'll get the absolute pressure minus the atmospheric pressure. So I have my gauge pressure because what is my absolute pressure or the total pressure? In the question is what? 4.2 atmosphere. These are not working in Pascal, atmosphere. Then minus the atmospheric pressure. This atmospheric pressure at sea level is always 1 atmosphere or 1.0 atmosphere. You see the first one was in Pascal. I used 101.325 Pascal. You understand that? So here minus what? 1 or 1.0 atmosphere. So therefore our final answer, which is the gauge pressure, is 4.2 minus 1 will give us what? 3.2 what? Atmosphere. As simple as that. I hope you are fine. I hope you are okay. Keep practicing. Do you understand that? Practice makes man the best. See you next time. Goodbye.